everyone, welcome back. I'm Domingos. I'm also known as DMA and appreciate when I'm called the DMA. Today we have this integral to solve and we're going to start from the argument of cos, which is ln of x squared. By remembering the rule of ln of a to the power n, when we have exponent in the argument, we can just simply multiply the exponent by the log of that expression. In other words, we send the exponent at the back multiplying. So if we apply this rule here, we're going to have now integral of square root of 1 plus cos of 2 ln x. That's what we're going to have. Now, getting here, we can just remember the rule that says, we can just remember 1 plus cos of 2 theta over 2, it's equal to cos squared of theta. But if we look, we don't have over 2 here. We don't have 2 as denominator. So we can isolate this expression. So that means the 2 that is dividing will come that side multiplying. So we can simply put 2 here, and 1 plus cos of 2 theta can be equal to 2 times cos squared of theta. So in our case, our theta is ln of x. So we're going to have then, this is going to be equal to square root of 2 cos squared of ln x. That is what we're going to have, dx. This is going to be square root of 2 times cos of ln x. Cos of ln x dx. So this is a constant. This is a constant, can come outside. So it's square root of 2 integral of cos ln x dx. So we reduce this expression to this expression. Now we can apply by parts. By parts, we're going to take first our u, which is the easiest expression to differentiate, which is cos of ln x. And if we take this as u, the remains, which is dx, becomes now our dv. So dv will be equal to dx. If we differentiate, the derivative of u will be 1, so du, to show that we differentiate in which respects to u. And the derivative of cos, we know that it's a negative sign. So it's going to be minus sine ln x. And since there is a composite, it's a composite function, so the derivative of the argument ln x is 1 over x. So we have 1 over x. And the integral here, since we differentiate in the left side, then we integrate on the right side. So we're going to have v equal to x. Now, we know that the formula says it's u times v minus integral v du. That's what we know. Now, if we multiply v times u, we're going to have x times cos of ln x minus integral. If we have v is x, and if we multiply x and x will cancel out, will be negative sine ln x. With this negative, they can already become positive. It will be plus sine ln x dx. Now, so what happened is now we have integral of sine of ln x. It's quite similar to the previous one, but that one is with sine, so we can already apply by part again. So applying by parts, we will take our u to be sine ln x, and the rest dv will be equal to dx. If we differentiate here, the derivative of sine, we know it's cos, so it's cos of ln x. But it's a composite function, so I derivate the argument because it's not just simply x, it's ln x. So the derivative of ln x is 1 over x. So I put 1 over x dx, and v will be equal to x because the integral of dx is x. So this will be equal, we multiply according to the formula, u times v. So it's x sine of ln x minus integral v du. X cancel with this x, so we have cos of ln x dx. Now, if we check, this expression is similar to the previous one, the one that we were given in the beginning. So if we keep applying by parts, we will still go back and we will still just be playing around. So what we do, when we get to expression whereby it's equal to the given one, we stop there. Now, since we integrate this expression, let's forget about the square root of 2 for now. Let's just worry about this expression. Since we integrate this expression, then we can say the integral of cos ln x dx, it's equal to, when we integrate, we got the result was this expression, which is x cos of ln x plus the integral of this expression we got as this expression. So we will have x sine of ln x minus integral cos of ln x dx. So this is negative, can come to the side positive. Then they will add one another. So adding two equal expression in maths will be equal to 2 times that expression. So if this comes to add, then it will be 2 times cos of ln x dx equal to this expression, which I can factorize x to be cos of ln x plus sine of ln x. Okay, now if we check, we have square root of 2 here in the beginning. So this, we can isolate this 2, can come here, divide this x. Now, since we have square root of 2, so to be, this expression is not the same as this one, so we can multiply square root of 2 both sides. So that means if we multiply square root of 2 both sides, we'll have square root of 2 here, and we will have square root of 2 here, plus c. So this integral, which is this expression which it was reduced from here, this is the solution of the integral. Okay. So if you enjoy, leave your like, your comment, subscribe, and most importantly, share with your friends.